Trigonometry, Chapter 3, Radian Measure in the Unit Circle. Section 1, Radian Measure. Video 2, Relationship between Degrees and Radians. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we learned what a radian was. In short, a radian is the measure of a central angle in a circle that intercepts an arc equal in length to the radius. Radian is a unitless measure, which means when we see an angle measure with no degree symbol, we assume the measurement is in radians. So here's a picture of theta equals 1 radian, or just theta equals 1. 1 because we have a central angle intercepting an arc whose length matches the radius of the circle. In this video, we determine the relationship between degrees and radians and develop a technique for converting between the two. To start with, let's establish a more rigorous method of determining the radian measure of an angle. We do this by revisiting a picture of an angle whose radian measure is 2, which you see here. 2 of the radii along the circumference gives us an angle measure of 2 radians. Now, the radian measure is 2 because that's how many radii match the length of the arc. If we're going to discuss radian measure in general, we need to represent arc length in general. The variable reserved for arc length is a lowercase s. This will permeate the entire course and is the same variable in calculus. In this picture, we have s equals 2r, arc length equals 2r. Since the radian measure is essentially asking how many radii are necessary to match the arc length, we can easily calculate radian measure by dividing the arc length by the radius. So in this picture, we would calculate theta in radians as follows. Theta equals 2r, the length of the arc, divided by the radius, the r's cancel, and we get a radian measure of 2. To generically represent this idea, we replace the specific arc length, in this picture 2r, with the generic arc length of s. So our equation goes from this to this, where we simply replace the 2r with the generic s. And this is our formula for calculating radian measure based on arc length and radius. If a central angle theta in a circle of radius r intercepts an arc of length s, then the radian measure of theta is theta equals s over r. And this shows why radians are technically unitless, because s and r have the same units, and those units cancel. Now that we have this, how can we use it to establish a relationship between degrees and radians? The answer lies in finding an angle that we can measure easily in both units. So let's consider one full revolution around the circle. We know in degrees theta is equal to 360 degrees. Excuse me, 360 degrees. But how many radians is this? Well, think about it. In order to calculate the radian measure, we need to know the length of the arc as we travel 1 revolution. Well, that's just the circumference. To calculate the number of radians in 1 revolution, we need to know the arc length, but for 1 revolution, that's just the circumference of the circle. And since the formula for the circumference of a circle is c equals 2 pi r, then that's the desired arc length. So in our formula, s will equal 2 pi r. Thus, the radian measure associated with 1 complete revolution is theta equals s over r, which equals 2 pi r over r. The r's cancel, and we get theta equals 2 pi. 1 revolution equals 2 pi radians equals 360 degrees. Now, since 2 pi radians equals 360 degrees, we can use this to calculate the number of degrees in 1 radian. Simply divide both sides of this equivalency by 2 pi. And we would get 1 radian equals 360 over 2 pi degrees, which reduces to 180 over pi degrees, which is approximately 57.3 degrees. That's a weird number. But although 1 radian is approximately 57.3 degrees, this is not the equivalency we will use in our conversions. Instead, you need to memorize any of the following. Either 2 pi radians equals 360 degrees, or cut that in half to make it say pi radians equals 180 degrees, Or either divide both sides by pi or both sides by 180. If we divide by pi, we get 1 radian equals 180 over pi degrees. But if we divide both sides by 180, we get 1 degree equals pi over 180 radians. Any of these will work, but I always use this one. Pi radians equals 180 degrees. It can always be used to set up a ratio to convert between degrees and radians, like a unit conversion. In the next video, we will practice converting between degrees and radians. Now you try. Pause the video and try the following. Which of the following express the correct relationship between degrees and radians? Let you ponder over them and think about it. All right, here's your fair warning. If you haven't paused the video, solutions in 3, 2, 1. The only correct one was the last one. Please see why the other ones were incorrect. Trust me, know that last one.